Good. Okay. So the question is, are these worldwide IQ differences genetic or cultural in origin? And there's several lines of evidence that we put forward to show that it's genetic. And I'll go very, very briefly through them, but there's one that I'm going to focus in on. And the first one is the worldwide consistency of the scores. If you buy into a cultural perspective, you would expect that when you change the culture in which you live, or magnify the environmental opportunities, you're going to change the IQ scores around. And in fact, you do not. What we find is that there's a consistency to these IQ scores over 80 different years of testing and a variety of different conditions. So for example, the South Asians who have moved into, say, Holland, have now, North Africans, Moroccans, and so on, are now in the second generation. And they've gone through the school system there, the nutritional system there, and they speak Dutch fluently, and yet their IQ is only up to about 89. In other words, yes, they've gone from 85 to 89 in one generation, and that's about the kind of level of improvement that you might expect under a genetic hypothesis. You might get 3 or 4 points due to the culture, because nobody's saying it's 100% genetic. It's at least 50% genetic, maybe as high as 60 or 80% genetic. So there's some movement due to culture, but the genes keep the culture on a leash. It may be a relatively moderately long leash, but there's a leash, and eventually you can't go any higher up. So that's the first argument for it being genetic. Maybe that's not a very strong argument. Let's go to the next slide. I'll skip over this basically because this is basically the race differences are most pronounced on the most G-loaded components tests. And the G-loaded component is that component which is the most predictive part. As it gets a bit technical, there's no point in belaboring it. Let's move to the next one, because this is the one I want to spend time on. The race differences are most pronounced on the most heritable components of the tests. And that's where I'm now going to get a little bit more technical. Go to the next slide. We've just published a paper in July of last year in the Proceedings of the Royal Society of London, and this is a very prestigious journal. I'm saying this not so much to toot my own horn as to convey the view that these studies are now in the scientific mainstream. They're now being accepted by the mainstream biology journals, which probably would never have happened 10 years ago. Now, they have not percolated up into the mainstream media. The New York Times or even The Economist is not going to run with this. But among academics, if I go to a scientific scientific conference where I've just presented these papers about 2 months ago, the people will listen to it and take it on board, and they recognize that there's some truth there, a lot of truth there. So this is now very, very acceptable kinds of data. We, in fact, in that paper that I just mentioned, published 2 samples. We had 2 twin studies. And it's the second study that I'm going to tell you about the most. If you go to the next slide, it's probably more understandable. This, again, is one of the puzzles, and there are 60 of them, from the Raven's progressive matrices. And there are twins who have done these puzzles. The most famous twin study in the world is the study of the Minnesota study of twins raised apart. So these were children who were separated at infancy. They were raised unknown to each other for maybe 30 or 40 years in different families. They grew up, they were then reunited by the research team and brought to the University of Minnesota, where they were then examined to see how similar they are. Even though they've been separated for 40 years, how similar do they end up being? And we all know they're very similar. And the question for me, because I had access to these data from Tom Bouchard at the University of Minnesota, was how similar are they on the various puzzles? So on some of these puzzles, the twins who've never met each other before are more similar to each other than on other puzzles. And the more similar they are to each other, the more genetically influenced it therefore must be the answers to that puzzle. And by the same token, since they are identical twins, genetically identical, any differences between them must be due to the culture or environments that they were raised in. So how different are they on each of these different puzzles? And so that was our origin of our study. How heritable, how similar were the identical twins raised apart, because that's the measure of heritability, and how different were they, because that's the measure of environmentality. Okay, if we go to the next slide. Oh yeah, okay, so this is the technical stuff. Basically, there's a whole lot of columns there, and I wanted to show them to you because it does show that there's real data here, and there's real science, so to speak, and real statistics. If you actually look down the first column, I said there were 60 different puzzles. What I'm showing you there are items 25 through to items 36. So there's 12 different puzzles. Let's take item 25. That's just one of the puzzles that you've already seen. The first three columns are three different ways of estimating heritability. I won't even bother going into them. The fourth column is the average. We took the average of those three different ways of calculating heritability. And then the fifth column is, as I said, the measure of environmentality. Okay, if we go to the next slide. This is all the different samples that we had. All these different people have been given those same tests. There were the twins themselves, there was the Roma that I mentioned in Serbia. Some other people had measured teenagers all over South Africa. There were whites, South Asians, blacks, coloreds. We ourselves, with Mervyn Sky that I mentioned, we collected data on these engineering students who are undergraduates from South Africa. We had East Asians, whites, South Asians, blacks, and coloreds. So these are all the different samples. And of course, it's possible to compare the different samples with each other. And if you go to the next slide, again, another data set, again, the items. So if you take the first row, item 25, the first column, that's the average heritability, how heritable are the scores on that item. The next column is how environmentally influenced are the scores on that item. The third column is what is the pass rate of that item? What percentage of twins, for example, passed it? Well, it was an easy item. 90% of the twins passed that item. But the next column shows that only 74% of the Roma passed that item. And then you can ask the question, well, what's the difference between the twins, the white people, and the Roma? And the answer is 16%. So there's a 16% difference on that item, on that puzzle, between the Roma and the twins. Now you might be able to see where I'm going with this. You've got different levels of difference. On some items, there's more difference. On other items, there's less difference. Is the magnitude of the difference predictable by the magnitude of the heritability? If so, it shows the differences are heritable. Or is the magnitude of the differences better predicted by the magnitude of the environmentality? In which case, the differences are due to the environment. And of course, both could be right. You could have some of the difference due to genes, some of the difference due to the environment. Go to the next slide. And again, this is all complicated stuff, but I just wanted to show you that this is the kind of publications there are. These show the magnitudes of the difference as a result of the heritability. Essentially, the differences between all the groups are most pronounced on the most heritable of the items. And they're not there on the environmentality of the items. Go to the next slide. This is just a different, we've just compared every possible group. So for example, if you go to the very bottom line, you've got the Roma. These are the people in Serbia who filled out the test, compared to black undergraduates in Johannesburg. So how big of a difference is between these two groups. And can you predict that magnitude of those two differences by how the Minnesota twins filled out their tests? And yes, you can. And the more heritable the test, the bigger the difference. And this strongly implies that the race differences, because they're there on the most genetically influenced traits, are themselves genetic in origin. Okay, if you move to the next slide.